So today we're going to learn how to use the zero product property. So if I told you A times B equals 0, I'm hoping you realize that that must mean that A is 0 or B is 0. I mean, I guess they could both be 0 also, but at least one of them has to be 0 because any number times 0 will give you 0. Okay, so if A was 0, doesn't matter what B is, when you multiply them, still going to be 0. If B is 0, doesn't matter what A is, A times B is still going to be 0. Okay, so that is the zero product property, and we can use this concept to help us solve quadratic equations. But we're going to start basic. So the zero product property is used to solve an equation when one side is 0 and the other side is a product of polynomial factors. So you got two pieces or more pieces even if you want, but we're just going to deal with two pieces multiplied together. The solutions of the equation, we discussed this the other day, are also called roots. So we're looking at this example. What value of x will make one part of the equation equal 0? We don't need both of them to be 0. We just need one of the pieces to be 0. So for the first one, we have x minus 4 times x plus 2 equals 0. So that must mean either this piece or this piece has to be 0. So we're just going to say, okay, if x minus 4 is 0, if that's the piece that is 0, what is x equal? In that case, x would be 4. If x plus 2 was the piece that equals 0, that must mean that x is negative 2. So our solutions to this equation would be 4 and negative 2. Okay, and once again, when you have these solutions and you plug them in, then we're not saying both parentheses are going to be 0, just one of them is going to be 0, and that's good. Because if we have 4 minus 4 times 4 plus 2, this piece is 6, but this piece is 0, so 0 times 6 is 0. If we have negative 2 in there, we'd have negative 2 minus 4 times negative 2 plus 2. This first part will be negative 6, but this one will be 0. So negative 6 times 0 is still 0. So we're just focusing on each of the parentheses one at a time and saying what would x be to make that parenthesis become 0. In the second equation, we only have one parenthesis, but that's okay, because technically we could put parentheses around that if we really wanted to. So we still have two polynomial pieces being multiplied together, two polynomial factors. So for the first piece, a lot of people forget about this one on the outside. Okay, 3x is 0. Okay, well that would mean x must be 0, because 0 times 3 would make this piece 0. For the other one, if we want x minus 8 to be 0, that would mean that x would be 8. So our two solutions are 0 and 8. Now these are pretty easy to see what the answer should be. You will get ones where it might be a little bit harder to see what the answer should be. Some of you are still going to be able to do these in your head, which is awesome. But if for some reason you're having trouble figuring out what the solutions will be, okay, really what we are doing is we're just taking each of these little tiny pieces and setting it equal to 0. So you can write it out as setting it equal to 0. So let's do 2n minus 14 times 3n plus 1. If I want this piece to be 0, and I can't tell off the top of my head what it should be, I'm just going to say 2n minus 14 equals 0, and I'm going to solve it. So add 14 to both sides, and divide both sides by 2. We get n equals 7. For this one, 3n plus 1 would be 0. We'd subtract 1 from both sides. 3n equals negative 1, and n is negative 1/3. For this one, we would say 1/2 x minus 3 equals 0. Okay, so we'd add 3 to both sides. 1/2 x equals 3. And then to get rid of that 1/2, we would multiply both sides by the reciprocal, which is 2. And x equals 6. And for this part, we'd say 12x plus 14 equals 0. Subtract 14 from both sides. And then divide both sides by 12. We do want to make sure we simplify that. So it'd be negative 7/6. So once again, just say what x would be to make each of the parentheses equal 0. If you're not sure off the top of your head, just create an equation, set it equal to 0, and then go ahead and solve that.